Hey everybody. I thought sine and cosine were the last ones, but then I looked back again. I was like, nope, there's actually two more that we need to make sure that you guys as pre-cal need to know. So the next one, and this one I'm going to actually use the whole page here, so therefore you're going to have to actually use like the like pretty much the whole paper there for this part. Kind of sort of. Yeah. So with this you're doing the whole side. So the next graph is called the greatest integer function. Right. So hopefully you have seen this one before. It's not like completely brand new, and you probably have seen it, but you just didn't know what it was or what it's used for, and probably haven't seen it. Some of you guys probably have never seen it before. So we're going to say it's f of x, and then we're going to put brackets right here. Now inside the bracket, we're going to do a line going straight down. And then in this bracket, we're going to do another line straight down there. So it looks something like this. And then we're going to put x in the middle. So this is the function that's considered your greatest integer function, or another one we call is a step function. And we call it a step function because once we get to it, once you actually see the graph of it, it kind of looks like it's like stairs going up, kind of sort of. So that's what we're going to do here. Okay, so we're going to graph it out here on this booklet. And again, you have rulers there, so you can actually pick one up and draw it out nice and pretty if you want to. It's up to you. All right, so here I'm going to go ahead and label these going up to 4, maybe 5. Let's go 5 in all directions. All right, and I'm going to label them 1, 2, 3, 4, 5, and then -1, -2, -3, -4, -5. And labeling is important. And then 1, 2, 3, 4, 5. All right, now with this, before we actually go to the graph part, I'm going to come down below it and actually talk about like what's happening or what's going on with this. So for example, let's say that we have this. Here, we get this, that, and we're going to do 3.5 in the middle. Let me say pretty much what is the value for this function, the greatest integer function, or greatest integer for 3.5. With that, your answer will end up being 3. Now, if you think about it again, this is called the greatest integer function. Integer. So that means integers aren't like decimal numbers like this. Integers are numbers like -1, 0, 1, 2, 3, 4, -5, -4, -3, something like that. Those whole numbers. It could be positive or negative, but it's a whole number. So when it comes to this part here, we have 3.5, and we're talking about what is the greatest integer. Now, this part right here hasn't gotten to 4 yet, so that means the highest integer that we can get to right now is just 3. So the greatest integer that this number has gotten to so far is 3. So that means any number between 3.0 to 3.9, the greatest integer between this and this is 3, because 3 starts is the integer, and then as you go higher and higher and higher, it doesn't get to 4 yet, so you can't say 4 is, you say 3 is. So here, the greatest integer is 3. Okay, So again, you can't go to 4 because that's not 4 yet. That's still on that part between 3 and 9, 3.0 and 3.9. Now, if we were to try like something like this, and we put 9.9. And again, with that, it is not 10 yet because it hasn't gotten to 10. So that means the highest integer that it got to was 9. So your answer here is going to be 9. So your greatest integer, if you look at from 9.0 to 9.9, or 9.9999999 forever, the greatest integer would be 9. Because we have not gotten to 10. Because we have not gotten to 10 yet. Okay, so with this, when we start graphing things out, we're going to start with 0, 0, and we're going to put a dot there. Because remember, 0 is an integer, so that's fine for this part. So whatever we're going to do is we're going to draw a line here, and then when we get at 1, we're going to put an open circle right there. And I'll explain why there's an open circle like once we finish this. All right, so at 1, we jump up to 1, put a dot there, a solid dot, and then we draw a line and get to 2 and put a circle at 2. Then at 2, we jump up and do a dot there, solid dot, to 3. Oops, sorry, it's past 3. My. So at 3, right there, let's go there. Right, and then from 3, we jump up to number 3. And we go over until we get to 4 and put an open circle there. And we continue on forever and ever and ever in both directions. So it goes up this direction and it goes back down this way also. So put a dot at the -1, which is an integer, and an open circle here. And then so on and so forth. So we put a dot at -2. Let's see, let's move it over some, right there. And then the open circle will be like right here. And so on and so forth. So we'll go down this way and it'll go up that way. And it kind of looks like you're taking stairs going up each time. Like if you're walking upstairs. Like, yeah. So here, with this is our step function, our greatest integer function. Now again, with each one of these, you see there's open circles on the end. Now with it, you can't have you're really not supposed to have a value here and a value here. Because when you get to -1 here, so sorry, when we're looking at -2, this line is here is for -2. So that means this is -2.0 right here is -2.1, -2. Sorry, going backwards. Sorry, no. So yep, that's right. That is absolutely right. Yep. So here we have 1. So this is like 0.1, 0.2, 0.3, 0.4, 0.5. So going to the negative numbers here, and then jumping down and going to negative numbers there. The negatives might look a little different, but it's okay. That's perfectly fine. And when we get there, we'll deal with more of those numbers again later on. But with it, we'll talk about these negative parts here because it looks a little different than what we would talk about. But it's gonna be okay. We'll talk about that in class. All right, but here, especially let's look at the positives for right now. So here we went from 0, it came over, so that's 0.1, 0.2, 3, 4, 5, 6, 7, 0.9. And then at 1, that is not an integer for 0. That has to jump up to be its own integer. So that means here, whenever we get to that next integer, there's an open circle there, and we jump up to the next line. So here that's 1, 1.1, all the way to 1.9. When we get to the next integer, which is 2, it's an open circle, and it jumps up here because at 2, the greatest integer value at that point is 2. So 2 wouldn't be at 1. The greatest integer at 2 is 2. And then the greatest integer at 2 here, when we get to 3, cannot be 2, so we have to jump up. So each time it's going to just follow the same process. And again, if that didn't make sense here, just like I can explain it again later on. So just raise your hand if you need to and call me over so I can explain it a different way so you can actually get it. All right, so that's our step function. That's the way it's going. All right, so when it comes to our domain and our range, your domain for this function, because it's going to go in both directions forever and ever and ever, it's going to go from negative infinity to positive infinity. And then your range, again, is going to go from the bottom of the graph to the top of the graph, going forever in both directions because it won't stop. So it's going to go from negative infinity to positive infinity again. It will not stop. And that is our step function or greatest integer function. All right, so we have one more, and we're going to do this on this paper here. And actually, this one's going to be even quicker. This one's called our rational function. Sorry, rational function. Rational function. All right. And this function actually looks like this, 1 over x. Or it could actually look like this too. So hopefully you have seen this one before, so it's not brand new or anything like that. So with the graph, and hopefully you already know what it looks like. Well, first off here, we're going to draw this out. But I hope you really do know what the graph looks like already. If you don't, it's okay. It's perfectly fine. But it's important that you do know it, though. Know the graph. If you look at this function really quickly, we know that if x equals 0, that will make this whole thing undefined, right? So no matter where it is, if x is 0, your x value is 0 here, that means it makes it undefined. So it means the graph cannot be equal to that. So here, we're going to do a dotted line or an asymptote here. So just like the exponential and log functions, we're going to do an asymptote right here, dotted line, because the graph will never touch that because that means it would equal 0, or the denominator would equal 0, which we can never have. It's undefined. All right, so looking at our graph here also, if we set this equal to 0, then in other words, finding our x-intercepts here, or our zeros, if we set this equal to 0, that means here this fraction can never be 0 because there's nothing you can put here to make this fraction equal 0. So you can put a 0 down there, that makes it undefined, which is not 0. If you put a 1 there, that's 1. If you put a -1, that's -1 there. And if you try any number, you will see that it would never equal 0. So here the x-intercepts will never be an x-intercept here because it will never equal 0. This fraction will never equal it. So that means here we have another asymptote, which is a horizontal asymptote this time. So here, the graph is going to look like this. So with our asymptotes in hand and on the graph there, our graph looks like this. So it won't touch the graph. It won't touch the x-axis or y-axis, but it will go forever and ever and ever in both directions. And if you put values in here, numbers for x, you will see that this actually does make sense to that. So if I put 1 in there, it'll be up at 1. If you put in like a decimal number, it would be like 1 over that decimal, which flips it, which makes it like a whole number. So it gets bigger and bigger and bigger each time. So here, the decimals actually do work for that part. And then down here, yeah. So with that, if you want me to go through that, like just raise your hand and I can come over and I can actually show you, like even the calculator or by hand, show you how that graph works out like that. Okay, but talking about domain and range, I'm almost out of time. We go from -infinity to 0, and we go from 0 to positive infinity. And the range goes from -infinity to 0, and from 0 to positive infinity. And you put the u in there because it means from here to here, and the u means and, from here to here. And if you need me to explain this more, just call me over. I got you. All right, that's it. That's the last two.